10.1, we're going to talk about probability. So a probability experiment is an action or trial that has varying results. The possible results of a probability experiment are the outcomes. For instance, when you roll a 6-sided die, there are 6 possible outcomes. A collection of one or more outcomes is an event, such as rolling an odd number. The set of all possible outcomes is called the sample space. So the first couple of questions, we're going to be finding the sample space. So example 1 says you flip a coin and roll a 6-sided die. How many possible outcomes are there in the sample space? So if I flip a coin, what are my possible outcomes? Heads or tails? Now if I roll a 6-sided dice, how many possible outcomes do I have? 1 through 6. But let's say I flipped heads first. I could roll 1, 2, 3, 4, 5, 6. But if I flipped tails first, then when I roll the dice, I could flip 1, 2, 3, 4, 5, or 6. So how many possible outcomes do I have? 12. If you just add them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes. Another way that we can find that is by taking the probability of each one happening. So that I have 2, or the possible outcomes of each happening. So I have 2 outcomes when I flip a coin and 6 outcomes when I roll a dice. And what's 2 times 6? 12. So you could just multiply. All right. Looking at number 1 on the bottom, find the number of possible outcomes in the sample space. So we flip 2 coins. So what are my 2 possible outcomes when I flip a coin? Heads or tails. So if I flip a heads first, then what are my possible outcomes for the next coin? Heads or tails. But if I flip tails first, then what are my possible outcomes? Heads or tails. So how many total possible outcomes do I have? 4. Again, you could find that because you have 2 possible outcomes for the first flip and 2 possible outcomes for the second. And you can multiply those together, you get 4. Now, if it asks for like a certain, or like what the possible outcomes are, you look at your like tree branch here. So if I flip 2 coins, one possible outcome is heads or heads. If I flipped 2 coins, one possible outcome is heads or tails. Another possible outcome is tails then heads. And then another possible outcome is tails and tails. So this is how I get the 4 possible outcomes. Let's do it again with number 2. So you flip 2 coins and roll a 6-sided die. So what are my possible outcomes when I flip a coin? Heads or tails? But then I flip another coin. So let's say I flipped heads the first time. What are my possible outcomes then? Heads or tails? But I could have flipped tails the first time. So what are my possible outcomes? Heads or tails? And then I roll a 6-sided dice. So I could have flipped heads, then flipped heads, and then I could roll anything 1, 2, 3, 4, 5, or 6. I could have flipped heads, then flipped tails, and then rolled a 1, 2, 3, 4, 5, or 6. I could have flipped tails, then heads, and rolled a 1, 2, 3, 4, 5, or 6. I could have flipped tails, and then rolled a 1, 2, 3, 4, 5, or 6. So how many possible outcomes do I have here? 24. Now you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and keep counting all of them. Or we know that we had 2 possible outcomes for the first flip, 2 possible outcomes for the second flip, and 6 possible outcomes when we roll a dice. So if you multiply all those together, you get 24. So we have theoretical probabilities, which is the probability of an event is a measure of the likelihood or chance that the event will occur. Probability is a number from 0 to 1. Does it include negatives? No, we're only looking at 0 to 1, so probability cannot be a negative number. But it could include 0, and it can include 1. and it can be expressed as a decimal, fraction, or percent. So here it shows all of the probabilities as a fraction. The next one as a decimal, and then the third one as a percent. You can write your answer as either a fraction, decimal, or percent. Either way would be right unless it specifies on the homework. So if it says like, as a fraction, what's the probability? It might specify, but it probably won't. So you could leave your answer anyway. 1/4 is the same thing as 0.25, which is the same thing as 25%. All of these would be the correct answer, bless you. But just make sure if you leave it as a fraction, it has to be simplified. Okay, example 3 gives us the sample space. So they flipped 2 dice, or rolled 2 dice, and showed us all the possible outcomes. So when 2 6-sided dice are rolled, there are 36 possible outcomes as shown. Find the probability of each event. So we're looking for when the sum is not 6. So I want to look at my dice. I'm going to figure out where the sum is 6, because that'll probably be a little bit less, and then I'm just going to count the ones that it's not 6. So 1 and 5, that adds up to 6. What other 2 dice add up to 6?
That one I did was like this to it.
What are the 2 dice?
2 and 4.
2 and 4. What else?
3 and 3.
3 and 3, and?
4 and 2.
And?
5 and 1.
Perfect. So I'm looking for where the sum is not 6. So how many of these 36 possible outcomes are not 6? 31. So if you count all the ones that are not highlighted, we have 31. Now to find probability, we do the event we want, so what we're looking for, over the total outcomes. So what are our total outcomes? 36. So you can leave your answer as 31/36. Could I simplify this anymore? Nope. So that's a simplified fraction. Or if you wanted to put it in your calculator, you could do 31 divided by 36 and get 0.86. Or you could leave it as a percent, and that would be 86%. Ready for the next one? So for B, we're looking for the probability where the sum is less than or equal to 9. So here I have 2 as the total, so that's less than 9. 3 is less than 9, 4 is less than 9, 5, 6, 7. All of these are less than 9. That would be 8. This one is 9, so we're looking for less than 9 or equal to 9, so that counts if it's equal to. That one would be 9, so we're good there. Not that one. That one is 10. So the sum is less than 9 or equal to 9. So how many do I have that are less than or equal to 9? How many? 30. Out of, what's our total? 36. Can I simplify this fraction? What does it simplify to? You can simplify more. 5/6. So you can divide the top and the bottom by 6. You could also just put it in your calculator. Do 30 divided by 36. And you get 0.833. So 0.83. Or what would this be as a percent? 83%. So going down, we're going to skip example 4. There's one question on the homework that's like example 4. It's number 13, but I put on Canvas, skip number 13. So you don't have to do that. But next we're going to look at the probability of the complement of an event. So the complement is the probability that it's not happening. So if I want something like, what's the probability of flipping a heads, the complement of flipping heads would be flipping tails. So like the other possible outcomes. In the example above, we found the probability that the sum is not 6. Well, the complement of that would be that the probability is 6. So to find the complement, we do 1 minus the probability that we're looking for, or the probability that we're given. So for number 4, how would I find the complement of this?
1 minus 0.45.
Awesome. 1 minus 0.45, which would be what?
Negative 0.55.
0.55. Remember, probability, is probability ever negative?
Yeah.
Nope, never negative, so it's got to be positive. So it's always 1 minus the probability. So what's 1 minus 1/4? 3/4. Next, I have 1 minus 1, which is 0. And then for number 7, 1 minus 0.03, which is 0.97. You can skip 8 and 9 because those go with example 4, so just get rid of them. So let's look at number 3. You flip a coin and roll a 6-sided die. What's the probability that the coin shows tails and the die shows 4? So here it's not really asking for our total possible outcomes, so it's going to be helpful to write out what's happening. So we flip a coin. What are the 2 possible outcomes when we flip a coin? Heads or tails. Then we roll a 6-sided die. So let's say we flipped heads first. What are possible options when we roll a dice after? 1, 2, 3, 4, 5, or 6. Say we rolled tails first. We could roll a 1, 2, 3, 4, 5, or 6. How many total possible outcomes do we have here? 12. Now we're looking for the probability that a coin shows tails and the die shows 4. So I'm going to go to where I flipped tails the first time and then rolled a 4. So how many times in the 12 possible outcomes do I have that I flipped tails and rolled a 4? 1. So it'd be 1 out of 12. All right. Next, we're going to talk about experimental probability. So it's based on repeated trials of a probability experiment. So the number of trials is the total number of times the probability experiment is performed, and each trial in which a favorable outcome occurs is called a success. So we have the number of successes divided by the number of trials, which is the same thing as what we want divided by the total. Now, experimental probability is different than theoretical probability. If I flip a coin, what are the chances of getting heads? 50%. 1 out of 2. Because there's 1 heads and 2 possible outcomes. So that's the theoretical probability. We're saying theoretically there's a 50% chance that we get heads when we flip the coin. So we're going to get heads half the time. But if I sit here and flip a coin 100 times, is it going to be that I get 50 heads out of the 100? No. So the experimental probability is not always going to be the same as the theoretical probability. Experimental probability, somebody sat here and flipped a coin, gave us the total number, which may not be 50%, but it'll most likely be close to it. So in example 5, each section of the spinner has the same area. The spinner was spun 20 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? Let's find the theoretical probability first. So our theoretical probability, how did you know that? Because there's 4 different equal sections. So what's the probability of me landing on blue? 1 out of 4, or 25%. What's the probability of me landing on yellow? 1/4, same thing. What's the probability of me landing red? 1/4, and green? 1/4. So our theoretical probability, if this were a perfect world, it would be a 25% each time. But somebody performed the experiment for the experimental probability, and they spun the spinner 20 times. So these are the results from experimental probability. So it's what we want, the number of successes over the total. So how many times did I spin red? 5 out of how many? 20. Can I simplify this fraction? 1/4. Is that the same as our theoretical? Yeah, so red's probably going to be our answer, but let's find the experimental probability of the rest of them. So let's do green. How many times did they spin on green? 9 out of how many? 20. How many times did they land on blue? 3 out of 20. And yellow? 3 out of 20. So which one is, for which color is the experimental probability the same as the theoretical probability? Red. Because they're the same. So 10 says, in example 5, for which color is the experimental probability of stopping on the color greater than the theoretical probability? So we said our theoretical probability was 1/4. Which color is greater than 1/4? Green. Awesome. So our answer here would be green, because green is greater than 1 out of 4. And if you can't tell that just by looking at the fractions, like sometimes your denominator is going to be different. If you simplified it or not, you could always change them to decimals to see which number is bigger. So example 6 says, in the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them have at least one pet. The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a dog? So how many have a dog? 916. Be careful, because it says what's the probability that a pet-owning adult, so we're only looking at the total amount of pet-owning adults. 1,328. This is a question that you might see on the SAT because it kind of tries to trick you. It gives you two totals, but you just have to be careful with the wording. The question says what's the probability that a pet-owning adult. So we have to look at how many total, what's the total amount of pet-owning adults? And that would be, yes. Could I simplify this fraction? Can I? Just by looking at it. Do you think I can simplify?
No.
Yes, we can, because they're both divisible by 2. They're both even, so we know that we can simplify. So if you left this as your answer, you'd get points off because it's not simplified. You can simplify your fraction, but my suggestion would be, instead of wasting the time trying to figure out what your common factor is or maybe making a mistake in the math, just putting it in the calculator and give me the decimal version. So 916 divided by 1328 would be 0.689, or what as a percent?
69.
We can just say 69%. So these two would be acceptable answers. Not the fraction, because it can be simplified. So I would say don't really stress about simplifying fractions, just throw it in the calculator. Give me the decimal. Just be careful what you're putting in the calculator. All right, number 11. In example 6, what's the probability that a pet-owning adult chosen at random owns a fish? So how many own a fish?
93 out of 146.
146. Be careful. 146 out of what? 1,328. Perfect. I can simplify this fraction. So instead of being careful with how we simplify, just throw it into the calculator. So 146 divided by 1328 would be 0.109, or what percent? 11%. So these two would be acceptable as answers.